Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update for June 1st of 2021. Coming to you from Yellowstone National Park, where snow's mostly melted, the roads are open, we're here to do field work. And I thought I'd do this update from the Grand Canyon of the Yellowstone, not just a gorgeous place, but it also has a spectacular geologic story to tell. And that story starts about 631,000 years ago, when the formation of Yellowstone caldera, the last really big explosive eruption from the Yellowstone system. Now that emptied most of the magma chamber and the ground subsided into that emptied space. And right after that happened, magma began to refill this emptied space, and it resulted in a structural uplift on the east side and the west side of the caldera. Now we're on the northern part of that east side dome called the Sour Creek Resurgent Dome. And that uplift resulted in all kinds of faulting. So there are all sorts of faults through here resulting from that uplift. Now about 500,000 years ago, 500,000 years ago, a large rhyolite lava flow erupted in this area, the canyon flow. And in fact, we're seeing the interior of that lava flow exposed in the canyon. So one of these huge lava flows, there have been about a couple dozen of them that erupted after the caldera formed, occupied this area about 500,000 years ago. Now over time, as the magma chamber heated water that was circulating in the subsurface, that hot water and gas began to rise, and it used those faults as a plane of weakness to get up to the surface. And as it rose, it began altering the rock. So that created some of the really spectacular colors that you see in the canyon as that rhyolite lava flow changed from the rhyolite minerals that are typical in the lava flow to clay minerals that are what we see in the canyon today. And at the surface, we had a hydrothermal system, a thermal area, something that might have looked like mud volcano does today. So this canyon actually gives us a picture into the interior of not only a Yellowstone lava flow, but also what it might look like under a place like mud volcano or the Old Faithful area today. Now the final stage of the history of this canyon occurred during the last glaciation. Ice about half a mile thick covered this region from 25,000, 30,000 years ago up until about 13 to 15,000 years ago. And as the ice receded, an ice dam formed across the river, backing water up into the Yellowstone Lake area. Now, of course, ice is a terrible material for a dam, right? Ice floats. And so the dam failed repeatedly, and torrents of water rushed through this area. Now, because there were all these faults that weakened the area, and the whole canyon now is made, this lava flow has been heavily altered into clay minerals, it's very weak. And the water just sliced through that area and cut the canyon we see today. We know it's a canyon that was carved by a river system because it has this V shape, whereas if it were a glacier, it would have a U shape, kind of like Yosemite Valley does today. So those torrents of water cut through and carved the canyon and allowed us this spectacular view into what a rhyolite lava flow might look like if it were heavily altered by all of this thermal and water activity that occurred, resulting in a system that today might look like what mud volcano or Old Faithful does. All right, well, that's the story of the Grand Canyon of the Yellowstone. Now let's talk about what happened in Yellowstone in terms of earthquake and volcanic activity during the month of May.
The University of Utah Seismograph Stations, which is responsible for the operation and maintenance of the Yellowstone Seismic Network, located 72 earthquakes during the month of May in the Yellowstone region. And this is a bit below average. Typically, we see between 100 and 200 earthquakes every month. There's been a quiet few months at Yellowstone. There were no swarms recorded during the month, and the largest earthquake of the month was a magnitude 2.5 located in the south part of the park, here near Lewis Lake, on May 23rd. In terms of deformation, we've also seen trends that have been going on for the last several years continue. This is deformation, vertical deformation at the White Lake GPS station, which is on the east side of the caldera near the Sour Creek Resurgent Dome. Each one of these blue dots is 1 day worth of data, and this entire plot spans the last 2 years. Downward trends indicate subsidence, and upward trends indicate uplift. You can see over this 2-year period, the net change has been subsidence of about 2 to 3 centimeters, about an inch every year. There are these isolated periods of no deformation or slight uplift, and these correspond to time periods, summer time periods, when the groundwater is being recharged by snowmelt. So we may start to see that sometime soon, since we're getting into the summer months at Yellowstone. Looking now at the west side of the caldera, this is the Mallard Lake Resurgent Dome near Old Faithful, we see the same trend of subsidence. So the caldera continues to subside, and that has been ongoing since 2015. And now looking at the Norris area, which is just north of the caldera, there really hasn't been much deformation since about January of 2020. There had been some uplift at Norris leading into 2018. It sort of leveled off in 2019, small amount of subsidence in late 2019, but since January 2020, Norris has been very steady, so no deformation there. And then finally, turning to everyone's favorite geyser, Steamboat Geyser in Norris Geyser Basin, it only erupted twice during the month of May. Now, unfortunately, we had some outages to our temperature monitoring station. This is showing the temperature in the outflow channel at Steamboat. We had some outages, which are shown by these gaps here. One of the eruptions of the month occurred on May 5th, right in this area here. And you can see we had been seeing high temperatures from minor eruptions, and then it dropped down to background temperatures. And these variations, these daily variations, are just solar heating. Basically, the sun comes out and heats up the thermistor. We started seeing more minor activity, which is these sort of more jagged lines, and then there was an eruption right in this time period here, May 31st, last day of the month, right around just before noon, local time. So the Steamboat activity continues, although only 2 eruptions during the month of May. That brings the total number of eruptions for 2021 to 12.
Well, that does it for the monthly update for June 1st of 2021. Now remember, if you have any questions, feel free to email us anytime at yvowebteam, that's all one word, at usgs.gov. Thanks for tuning in, stay safe, stay healthy, and we will see you next month. Bye-bye.